Okay, so last time we covered monopolistic competition, which was fairly short-lived. The more exciting parts of Chapter 11 with imperfect competition deal with oligopoly, when there's just a few firms that are acting strategically. So we're going to do a couple models. I'm going to not cover as thoroughly the Stackelberg model. So there's I guess, well, there's probably 4 at the end of the day, but there's a little bit of material here just in the essence of time of getting through stuff, getting onto the game theory. We're going to tread a little more lightly, and I'll highlight that for you on the material that we're going to tread a little lighter on. So we're going to start off by looking at firms that collude together. They act together as one. So they basically act like a monopoly. And then there's a Bertrand model where they choose prices. And then a Cournot model where we're choosing quantity. And then a Stackelberg model gets into sequential. I move first, then they move. And some of these names are important to know. Just as we get into game theory and other economic models, they'll say Bertrand pricing or Cournot equilibrium. And so that's why it's important to cover them here. So we're going to work through a couple different problems today. So what I just passed out to you was kind of our first setup of looking at 2 firms acting together. In previous, in your principles class, you may have called this a duopoly. Do you remember that at all, Sam? I didn't actually call it that in our class, but so we're going to be kind of breaking it down to 2 firms. It could be a few firms. These models are extended into 3 or 4 or whatever with the strategic behavior, but we're going to kind of just look at a simple case of 2 firms that are now engaging in collusion. So take a look at the problem you've got in front of you. Suppose that Squeaky Clean and BioBase are the only 2 producers of chlorine for swimming pools. The inverse demand curve for chlorine is this, where Q is measured in tons and P is in dollars per ton. Assume that chlorine can be produced by either firm at a constant marginal cost of $16 per ton, and there are no fixed costs. If the 2 firms collude and act like a monopoly, agreeing to evenly split the market, how much will each firm produce, and what will be the price of chlorine? So, first of all, are firms able to do that legally in the United States? No. So this idea of collusion is something that we kind of try to hold near and dear to our hearts in the United States in an effort to increase competition. So what, and keep competition alive and well. So what are the laws that are in the books that help keep this from happening? Sherman antitrust. So they're called antitrust laws in general. So anytime you hear the word antitrust laws, it's regarding collusive behavior, usually between firms. Okay, so how do we approach this problem? Like a monopoly, yeah. So go for it. You guys know the monopoly drill. Marginal revenue equals marginal cost. We're given an inverse demand curve, so it's already in the proper form that we like to see in terms of deriving the marginal revenue curve. As soon as you get an answer, tell me what you got. Quantity of 4 sounds good. Okay, so we're just acting like a monopoly. We've got a, what is it, a 32 inverse demand curve minus 2Q. And so we get a marginal revenue, constant marginal cost at 16, halfway through, I guess. We get something that looks like that. So how much is each firm going to produce?
Or two.
2. So that's one thing to know. So Q equals 4 as monopoly, but there's actually 2 of them. And so the agreement is that Q, let's call it, I guess Q, what do we got? Squeaky Clean and Biobase. So QS equals QB, Biobase, equals 2. They're all going to equal 2 is the production quantity for each one. Okay. How much profit will each firm earn? So profit for each firm. Profit equals total revenue minus total cost. What info are we missing? How much? Price. How do we get price? Plug it into what? Into the inverse demand curve. We got a quantity of 4. What's our number? Our inverse demand curve is 32 minus 2Q. 24 bucks. So we're going to charge a price of 24, cost of 16. We're producing 2 units. So depending on how you go back to the calculation, there was no fixed cost, remember? So we've got 24 times 2 minus 16 times 2, because average total cost then is equal to average variable cost, which is equal to marginal cost. So these are all equal to each other when there's no fixed cost. We saw last time how when there was fixed cost, the average was coming down, heading towards the flat marginal cost curve. Okay, so what do we get for profit? 16 bucks. Okay, so part B. Does Squeaky Clean have an incentive to cheat on this agreement by producing an additional ton? So does Squeaky Clean have an incentive to cheat by producing an additional ton?
Yes.
Yes. Why?
Because they'll make money off of it.
Yes. How much? Good. That's the one thing I wanted to point out, is that the price is going to come down, but it'll still be higher, right? So if just Squeaky Clean cheats, it's going to bump up the market quantity to 5, right? So that's going to cause the price to fall down to what? 22. Okay. But that additional unit only costs 16, so that's still a profitable thing to do. And of course, the other company has the exact same incentive as well. All right, so for part B, since and maybe we should be a little more careful. Because we'd be bringing down the price for the previous unit sold too. So we probably want to get back to looking at the total profit. But since price is greater than marginal cost, there may be incentive. So let's just put in parentheses, watch out for lowering previous units prices too. But otherwise, we got a pretty good possibility here. So just recalculate the profits.
So that's basically like how cartels work.
Mm-hmm. Yep.
Yeah, I saw that.
Yeah, we talked about cartels too. So this is the same arrangement for OPEC on why OPEC doesn't tend to hold up because each country has an incentive to produce more than their quota, more than what they're supposed to. So what is the new profit then? The one that produces more. So profit for, what do we call this guy? Squeaky clean? Yeah. So the question asks, the profit for squeaky clean. So now we got 22 minus 16 times 3. And that gives us our 18 bucks worth of profit. So they were making 16, now they're making 18. Pretty good deal. Okay. Part C, does Squeaky Clean's decision to cheat affect Biobase's profit? Yes, right? So for part C, we definitely got a yes because the price of the chlorine is coming down to 22. So now if we calculate the profit for Biobase, they're only getting 22. They haven't cheated yet. So they're going to still be producing 2. And so they're only making $12. Their profit went down.
Why is the price 22?
The price comes back to the total market production. So with Squeaky Clean cheating, the agreement was to produce 4. They're squeezing out 1 more unit, which then drops the market price to 22, which affects all the firms that are involved with the process. Okay, any other questions? Yeah, it's important to track with this one.
So is there a term that would be like the cost of producing that 1 more unit would be like sacrificing their agreement with the other person? You know what I'm saying?
Well, ultimately what we want to do is be longer term thinkers. In the short term, there's incentive to cheat. And then we want to think, well, where is this going to go in the end? So that's kind of where we're starting to head with this. Again, with your incentive to cheat, the other firm has incentive to cheat too. And so if you cheat, like I think what you were saying is the cost of the whole agreement going in the toilet, maybe it's not worth it, and there's some other dynamics there. So right now we're just kind of cranking out the numbers to see where those incentives lie. Okay, so part D. Suppose that both firms agree to produce 1 more ton than they were producing in A. How much profit will each firm earn? Does Squeaky Clean now have an incentive to cheat on this agreement by producing another ton? So part D was looking at each firm QS equal to QB equal to 3 question mark. So what happens in the market? How much is the total amount being produced? 6, which comes back to Sam's point that we have to now calculate with 6 units of production in the entire market. Where is that going to drop to? And what's that answer? 20. Okay, so profit for Squeaky Clean is going to end up being the same as the profit for Biobase, which is 20 minus 16 times 3. Gives me 12 bucks. Is there incentive to cheat on this agreement? No. Why?
Because if you move it up, you put 7 units in the market, your price is then
Good.
solving for the profit for the firm that cheats, their profit's only 8.
Right. So your profit actually falls. Right. So no incentive to cheat now. instance, profit for squeaky clean at a squeaky clean quantity of 4 leads to profit of 8, which is worse off than where they are right now. So therefore, that agreement would now be kind of stable. Yes.
Is that a risk that companies such as Squeaky Clean and Firebase would take?
Yeah, it would be. It's just a more stable agreement, right? So, is it the perfectly competitive arrangement? No. But it is stable. So it's a situation where neither player would want to change their choice given what the other one is doing. Nash equilibrium. So that would be a situation of a Nash equilibrium where neither one would want to modify their behavior, taking as given what the other one's doing. So there's no incentive. So it is a Nash equilibrium. Okay, now I'm going to add kind of a part E onto this one. And let's take away the collusion. Suppose there's no collusion. So maybe they got busted and antitrust laws, or they heard that the government was investigating them or whatever. So they said, screw it, we're not going to do that anymore. No more morning meetings at the Starbucks to talk about our production quantities. So, if they were, let's just go ahead and say at 24. Let's go back to the original equal. Well, we can we can stay right at this Nash problem. So no collusion now. The price of chlorine is equal to whatever we left off with. What was it? 20. Has that changed anything? Has that changed anything? Is chlorine differentiated or homogeneous? Pretty homogeneous. If you've shopped around chlorine, it's pretty much, there's some sort of chemical formula, which I'll let you go over to the biology department to figure out. But let's note chlorine, chlorine is homogeneous. What does that mean for the customers of chlorine? They don't give a rip. They'll go to any place. And so what's going to drive their decision of where to go? Price. Who's ever got the lowest price? That's where I'm going. You search online. There's 10 different vendors. As long as they're all equally reputable and you feel like you're pretty secure in getting it sent to you through eBay or whatever, boom, pick the lowest price, right? So now what's going to happen if Squeaky Clean cuts their price to $19.99? They'll go all the quantity. Yeah. So they're going to take the whole market, right? So imagine what their profits are. So if Squeaky Clean, if the price for Squeaky Clean equals $19.99, then all customers go to Squeaky Clean. And let's go ahead and calculate the profits then for Squeaky Clean.
They're producing still 3 or
They have all 6, yep. Under this setup. So the profits for Squeaky Clean equals $19.99 minus 16 times 6 equals how much? $23.94. So $23.94? Okay. And that was compared to 12, right? Pretty good jump in profit. Double, right? Double your profit. Pretty good incentive to do that. Well, Biobase is no dummy. What do they do? 1998, so now all of a sudden we're in a price war. And if they're operating strictly on prices, where is this thing going to gravitate to? Again, there's no collusion allowed, so all they can do is go on price. Price equals marginal cost, competitive solution. That is the Bertrand pricing model. So that's our, what's unique about this is we've got a situation where there appears to be a lack of competition with only 2 firms, right? But we're getting a competitive result. So that's what's kind of unique about the Bertrand pricing, is that because of the nature of the product being homogeneous, which is a key ingredient to this, if we start to allow the bio-based company to offer extra perks and changes, maybe it's more of a retail environment instead of shipping. They come into the store and there's soft music and they make people feel good. They got extra service, right? So again, if we start to differentiate the product, even though the chlorine is still homogeneous, if we start to bundle that with other things, then we can get some different results. It won't necessarily go down to this price equal marginal cost setup. But that's the idea here. So in the long run, competitive price cutting will lead to price equals marginal cost or profits equal to 0, which is our competitive solution. With only 2 firms. As long as we knock out the collusion. John?
Would quantity stay at 6 or would it drop back down to equilibrium of 12?
Well, here's the thing. By getting all of the market, did they instantly become a monopolist? Are they the only seller? No. That's a key difference. So, yes, they got all the market, but no, they're not the only seller in the market. In fact, Biobase is sitting fat on a whole ton of inventory, right? So it starts to set up what we call a contestable market, where there's a threat of entry into it. And so if there's small barriers to entry, you can see this in other places too, where the threat of entry into the market keeps us closer to the competitive solution. So they can't act strictly like a monopolist now, because then we would be back to quantity of 4. We saw this is the monopoly model. So if these 2 firms merge together and become 1, quantity equals 4. And maybe they would decide to split production, 2 to the plant in Kentucky and 2 to the plant in California or whatever, but that's their decision. They would be a true monopolist. They gained market power. So it'd still be at, well, it wouldn't even be at 6. Once we got out to the, in the long run, the price cutting, people would still be wanting to buy more as they cut the price, right? So if we cut the price to $19, we just used the demand curve we eventually cut price all the way to where demand equals marginal cost.
But if you're having two, this is where I'm kind of confused, if you're having two firms that are lowering their price and trying to take the whole market, so, Squeaky Clean made 6 at that point, then Biobase, wouldn't they make 6 as well, trying to lower their price lower than Squeaky Clean?
They're competing on price, and then they're
Yeah.
supplying that quantity to the market.
Because I'm just thinking, wouldn't you have the quantity that would be greater than the quantity where marginal cost equals price?
Yeah, I mean, eventually, if we tell a dynamic story, which can be dangerous but yet fun to do, I mean, if you want to go back to kind of real world, maybe there'd come a point where they'd drop price below to get rid of that excess inventory, realizing that, hey, that's not going to work in the long haul. I'm absorbing a loss. And then they'd raise the price back up to 16. You're trying to kind of tell an inventory story of where I've got excess capacity.
Yeah.
And so that type of dynamic thing would lead us to eventually this being our long-run equilibrium at 16 in that quantity.
You're saying that happened here.
And in fact, part of what you're bringing up, in the long run, we don't know if it would be 50-50. There's two firms in here that, that each tries to sway, and so the fraction that Biobase gives might get a little bit bigger, and then, might go back and forth, who knows. Because it's really, for the customer now, when we hit long-run equilibrium and they go to the internet and it's $16 from Squeaky Clean and it's $16 from Biobase, what does the customer do in deciding which one to pick? Flip a coin, right? I mean, maybe it happens to be the one that they bought from last time because they don't really care and they didn't have any problems. That's where we start to touch on a Stackelberg model, where it might be important for one company to make the first move into the market. So we could get different results if Squeaky Clean was the first one into the market. They kind of got this market share. It's kind of a coin flip for the customers. They're acting competitively, and people just tend to stick with Squeaky Clean. And so prices would still tend to be sticky at that market price. Squeaky Clean wouldn't have any incentive to deviate because they've already got a large market share, and they're earning good profit, right? Or whatever, fair profit on that volume. And the smaller firm can't cut price because they'd be operating at a loss. So, again, it's kind of our nature of equilibrium. All right, anything else there? Okay, Cournot is a little bit different. So, Collusion, the firms are acting together. Bertrand, they're competing, but competing on price. With the Cournot model, they are thinking about a capacity constraint. So, did I miss one? Okay. So perhaps imagine that if one of the firms in this example doesn't have the capacity to supply 6, right? So if that's the case, and we know that this is how many needs to be, and maybe one firm only has the capacity to supply a couple, then it might behoove the other bigger firm that has larger capacity to go ahead and let that guy undercut him. He can't supply the whole market anyway. And so then we're almost like in a market segmentation type of scheme. We're going to let him do his little bit at a cheaper price, but then I'm going to catch the rest of the market at the higher price, right? Now, in the long run, maybe that guy can scale up production and there'd be problems with that. But that's the idea of what's going on in the Cournot model. So, 11.2. Oil Pro and Grease Tech are the only two firms who provide oil changes in a local market in a Cournot duopoly. The oil changes performed by the two firms are identical, and consumers are indifferent about which firm they purchase an oil change from. The market inverse demand curve for oil changes is 100 minus 2Q, where Q is the total number of oil changes in thousands produced by the two firms. So QO plus QG is the kind of market quantity, big Q. Oil Pro has a marginal cost of $12 per oil change, while Grease Tech has a marginal cost of $20. Assume that neither firm has any fixed cost. So determine each firm's reaction curve and graph it. All right, so we've got a number of things going on here. So what are some things that jump out at you? How do you want to approach this one, first of all, with the information that's given? I think when you see a problem like this, you might start writing out some of the equations. And what did they give us in the problem? Two different marginal costs. And what's that demand equation? Whose demand curve is that? Which companies? It's the markets. Good. So it's not the demand for any particular firm. And so the idea with this is that the quantity, the choice variable for the companies is the quantity that they're going to bring to the market. So we're not thinking about them choosing the price, but it's the quantity that they're going to bring. And then at the end of the day, this guy brings 10 units, this guy brings 20 units, there's a total of 30. That's going to be the market price. See how the choice variable is a little bit different. We're not choosing a price, we're just choosing a quantity. And that's the key difference here. So note that down. So note, each firm chooses a quantity to provide to the market. Then the market, and I guess we'll just say market demand, the consumers, determine the price for a given market supply, quantity supplied. So again, kind of helpful to jot down what's going on with each curve. We got the marginal cost for, what was it, Oil Pro has a marginal cost of 12. And Grease Tech, marginal cost of 20. What do these curves look like then in our normal price quantity space? In that space? Lines. Vertical or horizontal? Horizontal. Okay, so just kind of keep those basics as you put down equations like that, start to envision what that's going to look like graphically. And then the demand curve is what? P equals 100 minus 2Q. Well, that's what we want to think about, whether we're dividing it by half or how do we modify, kind of given my statement up here, how this thing's going to play out. What does this thing look like if we were to put it into greater detail? Yeah, the sum of the two. So we don't want to divide them by 2 because we're not assuming that they're dividing the quantity equally, right? So what we kind of want to think of is that big QS, if we want to call it the market quantity supplied, and maybe I just want to say Q just so I don't add another variable in there. But the quantity supplied is equal to the quantity from Oil Tech plus the quantity from, or Oil Pro and Grease Tech. And so now go ahead and write that in as a first step. So price equals 100 minus 2 QG, or QO plus, oops, minus 2 QG. Okay. Now, what would the firm's demand curve look like if we were to pick off the individual demand curve? So imagine doing this. We're trying to find the demand for, I guess we'll take oil tax. How would we start to construct a demand curve for oil tech that involves grease, oil pros, that involves grease tech's quantity? What would that end up becoming in terms of this demand curve?
Talking about the sums of the demand curves at that point? Like, I know at one point.
Possibly, yeah, in a way. But also we're measuring is oil pros quantity here. So that's the quantity that oil pro will supply to the market at various prices. We've got what the market demand curve looks like. We know that the market quantity is going to ultimately be the sum of the two. How could you graph that relationship?
Does it go to where price equals marginal cost?
I don't want to even bring in marginal cost yet. I just strictly want to think about the demand curve.
Put it in terms of quantity of
Okay, so how would you graph it then? I'm trying to figure out, like, how could I actually find a point here if this is Q1, you know, what's this? You know, that's kind of what I want.
Like if they sold all of the market, like if quantity of grease tech equals 0.
Well, I guess what's missing link in order to be able to go up to this curve, hang a left, and read off a number?
We need to know
What do we need to know?
we need to know what the choke price or whatever? Or not?
Well, we got a choke price of 100. We got to know what grease tech's production is, right? If we knew that, then we could solve it. Because how does this thing collapse down then? If grease tech's bringing, I don't know, 10 units, can't we graph it then? If you know that grease tech's bringing 10 units, you could graph it, right? Because look, 10 times 2 is 20. 100 minus 20 is 80. 80 minus 2Q, boom. So intercept form. I know how to do that, right? So for a given quantity of grease pro, we could conceivably graph this thing. And then if grease pro's quantity goes up to 11 from 10, what happens to the demand curve? It shifts, right? So if we go to 11, 2 times 11 is 22. 100 minus 22 is 78. My intercept just dropped from 80 to 78. It's a shifter at that point, right? Just like we learned before with income or other variables that we hold constant, this time what we're holding constant is the quantity of the other person's product, which we know could vary. And so this sets up, where we're ultimately getting to is the reaction curve. How is my quantity going to change based on your quantity? And so that's ultimately what the question asked for, to determine each firm's reaction curve and graph it. Before we go there, though, I wanted you to think about this. So let's go ahead and write that out. If quantity of grease tech equaled 10, then this intercept becomes 80. And just this is kind of a quick and dirty diagram. now we'd be able to figure out our line. Now, I'm not even sure if I was to scale or not, but this would become 80. Maybe the best thing to do, so we don't need to muddy up this problem any more than I'm probably already doing, is do this. But I want you guys to understand this, that if grease tech equaled 11, then this intercept would shift around. So that you got in your mind that that's what's really happening with how the firm is perceiving their other player. Now, to contrast this with perfect competition, why did we not see that in perfect competition? Yeah, unlimited amount of firms. Every firm's a drop of water in the bucket. One drop of water into this bucket, and it doesn't change the price, right? So if each firm's so small relative to the overall market, they don't have any impact. So that's where this is different now. One firm does have an impact on your behavior. Okay, so if we had a marginal revenue curve then, what would it look like? Let's take this demand curve here. What would its marginal revenue curve look like? And I'm looking for an equation. So what would be the marginal revenue when Grease Pro is at a quantity of 10? Good. 80 minus 4Q. All we've done is the same trick we did before. Marginal revenue is twice as steep as demand, still has the same intercept. And so we just draw a marginal revenue curve.
And that's 4 times the quantity of oil?
Yes. It's because that's what we're measuring here is the Oil Pro's situation. Okay, so we don't have to plug in actual numbers. Can't we leave that float? In other words, I didn't have to give you quantity of grease, pro grease tech equal to 10. We could have just left it dangle, right? And if we leave it dangle, then that gives us the full marginal revenue function where the quantity for Grease Pro is left to be determined. So now I want to think about how the actual marginal revenue function looks like. So from this demand curve, more generally, the marginal revenue for Oil Pro is 100 minus 4QO minus 2QG. So notice we only put 2 times the slope for the one that we're actually monitoring, Oil Pro's. So this is Oil Pro's marginal revenue function, leaving Grease Pro's amount yet to be determined, or to kind of dangle out there as a function. Now, Grease Pro's, Grease Tech's marginal revenue function is going to do the same thing, right? Except we're going to multiply. Now we'd be graphing Grease Tech on the horizontal axis. So their marginal revenue function would be 2Q of Oil Tech minus 4 quantity for Grease Tech. The Tech and the Pro are going to, I should just be saying grease and oil probably, but I'll continue to fight it. I'm gonna figure it out.
So is marginal revenue for both
So it's just showing like the amount of quantity that they're taking away from the whole, and then you just figure it out.
Yeah, we're letting the choice variable for each one. This is marginal revenue for Oil Pro because Oil Pro is choosing this. This is ultimately going to be given to us. And here, this is the marginal revenue for grease tech because ultimately Oil Pro's quantity is going to be given to us. And then we'll just solve it out just like, that's why I wanted to start you off your brains with this, is like whatever they do, that's the impact that it has on the functions. Because the marginal revenue function here at a quantity of 10 looks like that. The marginal revenue function here looks like that. They all kind of move in harmony together, right? Twice as steep. Okay. So
is that the reaction curve?
we're getting close. We're getting very close, dangerously close, in fact. So to find reaction curve, how will they actually react to each other? Well, they're going to do it in a profitable way. So, what does Oil Pro do to maximize profits? Produce the quantity where marginal revenue equals their marginal cost, which was different. Same thing for Grease Tech. They're going to maximize profit where their firm's marginal cost equals marginal revenue. So now go ahead and do that. And when you do it, in fact, I'm just going to add on to this up here to just show you generically. So these guys were 12, which is marginal cost for Oil Pro, and 20 for marginal cost for Grease Tech. What I want you to solve for then is the quantities for each one. If you look at this mess, if you kind of step back from the mess, you've just got some numbers and you've got the quantities. So if we're looking for Oil Pro's reaction curve, it's a function of what Grease Tech does. So solve for QO and throw the rest of the junk over to the right. Since the marginal costs were different, your answers, your reaction curves are going to be slightly different. And now, you can see that these two concepts are similar. Marginal revenue equals marginal cost. Here we're in our normal dollar and quantity space. Your reaction curves are technically in quantity space, right? So if you graph these in quantity space and put the quantity of Grease Tech up here and the quantity of Oil Pro down here, we get, this one is y equals mx plus b. So this one's already in the form we need it to be to graph it. So Grease Tech's reaction curve looks like this. And Oil Pro's is going to have a, once you flip-flop these around, 22 times 2 is 44. We're going to get a curve like this. And so this is reaction curve for Oil Pro. And this one is the reaction curve for Grease Tech. we got to pause there. But we now have enough information, and you remember how it seems like a lot of exciting things in economics happens where the two lines cross. This ends up being our point, where we're going to figure out what each one's reaction will be to the production of the other, and that becomes our equilibrium.